This is section 11.8, the ideal gas law. What you'll see in class is that I always introduce the gas laws with this section. I think it's the easiest. You can extract all the other gas laws from this. So the ideal gas law is PV, pressure times volume, equals N times some constant called R times T. So essentially it's PV equals NT. Well, anything you want to solve, you can put the others on the other side and solve for it. Okay, so the N's and the T's go on the bottom, and the P's and the V's go on top. Okay, the R also, in order to use the ideal gas law, you're going to need a constant, and that constant is R. And there's a couple different forms. It depends which units you're using. Remember, there's lots of different units. So if you're using liters and atmospheres and kelvins and moles, then there's one R. If you're using different configurations, there's a different R to match that. And R is a constant. It's something you look up. It's just a number that makes the math work. Okay, but in the case where you have all five of these terms, you will need the gas constant. We'll look at that in just a second. Okay. So the relationship between the first four properties, P, V, N, and T. Okay, if you were to take PV and divide by N and T, whatever you end up with that makes the math work is a constant. Okay, it's just a number that never changes, called R. You would think that the constant should be 1, but it doesn't. It's not 1. There is actually a number that will make all of these relate properly to each other. And when you rearrange it, you end up with the ideal gas equation, which is PV equals nRT. Pressure times volume equals number of moles times a constant that we'll learn times temperature. Temperature is in Kelvin, N is in moles. Volume can be in anything that you want as long as it cancels with the R. There's your problem. The R is a specific R for the units that you're using because the R makes everything cancel properly. So there is an R for all of these different possibilities. I have always simply just tried to use the same ones all the time. So my pressure, I always put in atmospheres. My volume, I always put in liters. And my temperature, I put in kelvins. If you do that, then there's an R that I remember, 0.0821 or something like that, that always will work as long as your units are the same. If you want crazy units, you can use them. You can use any crazy units you want. But you have to make sure that the R that you have looked up on the internet or in a book somewhere is the R that you're wanting for the units that you have. And that's all it is. So a constant is making the math work. That's what the R is. This is another value for the universal gas constant. Okay, that's the R, is obtained using millimeters of mercury for the pressure at STP. What is the value of R when the pressure of 760 is placed in the R expression? So if you know that it's 0 Kelvin, which is 273, 0 Celsius, 273 Kelvin, if you know that it is 1 atmosphere, which is 760 millimeters of mercury, then what does R equal? You simply take those numbers, and when you do the addition or multiplication and division, you get a number that's R. So that's how they found it, by the way. That's what they did. Okay? And they realized that millimeters of mercury, liters, Kelvin moles, is going to be 62.4. Okay, that's the R, 62.4. If you have atmospheres instead, you have a different R. The R will be whatever number works when you fit all this in standard temperature and pressure. Okay, so if you have liters, atmospheres, Kelvin moles, it's 0.0821 liters, atmospheres, Kelvin moles. If it's millimeters mercury liters moles Kelvin, it's 62.4. So just because I don't like trying to memorize 5 different things, I just make sure all of my pressure is in atmospheres, all my volume is in liters, and my temperature in Kelvin. And then I remembered one of these, 0.0821. It seems like this might be easier to memorize, 62.4, but you have to make sure everything is in millimeters of mercury to do it. But then once it is, it all works. Okay, so here's an example. Laughing gas, which you get at the dentist, everybody is crazy after it. 20-liter tank contains 2.86 moles at 23 Celsius. That's room temperature. What's the pressure in the tank? Okay, well, PV equals nRT. That means P1V1 over nRT 1, and then you're solving whatever you're solving for. So PV equals nRT. Okay, here's all of your things. Get it, organize your thinking. Okay, PV equals nRT. Solve for P because they're asking for pressure. So that means it's nRT over V. Fill them all in. That's all that you're doing. You're just moving the furniture, filling in, and doing the multiplication and division. And that's how you're doing it. Now notice if you had pressures in atmospheres instead of millimeters of mercury, you would use a different R. You would use the 0.0821 rather than the 62.4. So 5 liters, 0, 20 Celsius, 8 atmospheres. How many grams of oxygen are in the cylinder? Well, you have to go through the periodic table again to do this. So you organize your thinking. What do you have? Solve for the number of moles. Okay. So if you want grams, then you're going to have to go from moles. Everything goes to moles through the periodic table. So once you solve for moles, you have your answer. Divide your numbers. You end up with moles. And then you know in 1 mole, that's the number on the periodic table. Periodic table is 1 mole, and then you just use it as a conversion factor. And you end up with 18 times 32, and it's 5.8. Okay. Last one. Grams. Okay, so you have grams of gas. That means grams has to go through moles, and moles is from the periodic table. So you say there are however many grams in 1 mole on the periodic table. Go from grams to get there, right? So we don't know moles, but we have grams. So to do that, you're going to say you have this many grams. You have this many grams times 1 mole divided by that many grams. Okay. Again, I don't like doing this without writing. I would do this on the board, and we would write this together. So we'll look at these.